Welcome to Spelling Bee Ninja, your go-to podcast for educational content that fuels curiosity and inspires learning. Join us as we explore exciting topics in science, history, and beyond, designed especially for students like you. We invite you to subscribe to our podcast for free and embark on a journey of discovery with us. Together, let's unlock the secrets of the universe and learn something new in every episode. Today, we're diving into an essential part of physics, forces and motion. These concepts explain how and why objects move, making them fundamental to understanding the world around us. Let's start by discussing what a force is. A force is a push or pull that can change an object's velocity. Think of it this way: when you kick a soccer ball, your foot applies a force that sends the ball rolling. Forces are measured in newtons, abbreviated as N. There are two main types of forces: contact forces, like friction and tension, and non-contact forces, such as gravity and magnetism. One of the most influential scientists in understanding motion was Sir Isaac Newton, who formulated the three laws of motion that are foundational to physics. Now, let's explore Newton's first law of motion, often called the law of inertia. This law states that an object at rest stays at rest, and an object in motion stays in motion unless acted upon by an unbalanced force. Imagine if you're in a car that comes to a sudden stop. Your body keeps moving forward. This is inertia in action. Inertia is the property of matter that resists changes in motion. Next, we have Newton's second law, which is critical for calculating how forces affect motion. This law tells us that force equals mass times acceleration, or F equals ma. This means that the greater the force applied to an object, the greater its acceleration will be, provided the mass stays the same. For instance, if you try to push a heavy box versus a light one, you'll find that it's much easier to get the lighter box moving. Now, let's consider Newton's third law, which states that for every action, there's an equal and opposite reaction. This means when you exert a force on an object, that object exerts a force back on you with equal strength but in the opposite direction. A practical example of this is when you jump off a boat, you push backward on the boat while it pushes you forward. This principle is also how rockets work in space. They push exhaust gases backward to propel themselves forward. Now it's time to discuss speed and velocity. Speed is a scalar quantity. It measures how fast something is going but doesn't provide direction. For example, you might hear someone say a car is going 60 miles per hour, that's speed. However, when we include direction, we get velocity, which is a vector quantity. Saying a car is going 60 miles per hour to the north gives you both speed and direction. Understanding how these quantities differ is key, especially when we move into acceleration, which measures how quickly an object's velocity changes. Acceleration can be positive when speeding up or negative when slowing down, which we also refer to as deceleration. The formula for calculating acceleration is E equals v final minus v initial divided by time. When we talk about forces, we can't overlook friction. Friction is a force that opposes motion, acting between two surfaces in contact. It comes in three types: static friction, which keeps an object at rest; kinetic friction, which occurs when objects slide against each other; and rolling friction. Without friction, we would slip and slide everywhere. For instance, try walking on ice without it, quite a challenge. Next in our exploration is momentum, which is defined as the product of mass and velocity, or P equals mv. Momentum is a vector quantity, meaning it has both magnitude and direction. What's fascinating is that in a closed system, momentum is conserved. This tells us that the total momentum before an event equals the total momentum after an event. For example, a heavy truck moving slowly can have the same momentum as a light car moving fast, demonstrating how mass and speed are interconnected. As we move on, let's touch on centripetal force. This is the force that keeps an object moving in a circular path. It always points toward the center of the circle, like gravity that keeps the moon orbiting around the Earth. Centripetal force is crucial in many everyday situations, like when cars turn corners or when a ball swings on a string. The last concept we'll cover today is work and energy. work is done when a force causes an object to move in the direction of that force. The formula for work is W equals F times D, where W is work, F is force, and D is distance. The unit for both work and energy is the joule. Two important types of energy to know are kinetic energy, which is energy of motion, and potential energy, which is stored energy. Understanding these concepts is crucial to grasping the basics of physics and how our world operates. To recap, we've explored forces and motion, two fundamental concepts in physics. We've learned about different types of forces, Newton's 3 laws of motion, and the differences between speed and velocity. We also discussed acceleration, friction, momentum, centripetal force, and the principles of work and energy. These concepts are not only key to physics but are also very much part of our everyday lives, shaping how we interact with and understand the world around us. Thanks for joining us today on Spelling Bee Ninja. We hope you're inspired to explore these concepts further and continue your journey in the world of science. Don't forget to subscribe to our podcast for more amazing educational content just like this. Until next time, keep asking questions, stay curious, and keep learning.